Before I start with shear and moment in beams, let us have a short review of our past topics. So we have computed for stresses in different objects subject to different types of loads. So dito, we will also compute for stresses in beams. And we have to start with what we call as the shear and moment equations. So before that, let me show you some examples of beams. So yung mga horizontal elements or members that you see in these structures are what we call as beams. So what is a beam? The term beam refers to a slender bar that carries transverse loading. That is, the applied forces are perpendicular to the bar. In a beam, the internal force system consists of a shear force and a bending moment acting on the cross-section of the bar. So sa figure na to, this represents the beam and this represents the load. So we have already encountered, so I'm sure naman na na-recall ninyo sa mga ibang discussions yung itsura ng beam which undergo different types of loading. Pero dito, we will analyze the internal effects of those external forces. Kasi yung binanggit dito na applied forces, yan yung nakikita natin na external loads na naka-apply sa beam. So, ang gagawin ng external loads na yan, makikreate siya ng internal forces. So, anong gagawin nitong internal forces? So, this will give rise to two kinds of stresses on a transverse section of a beam. And these stresses are the shear stress due to the shear force and bending or flexural stress that is caused by the bending moment. Okay, so we know that a shear stress is a type of stress caused by a force which is parallel or tangential to the area. And then yung moment, we know that this is force by distance or merong parang rotation na nangyayari doon sa force kapag meron itong perpendicular distance from a given moment center. Now, meron binanggit dito na bending moment. So, that is because yung external load, ang ginagawa nito ay binebend yung beam. Or, as we will see in the next slide, merong sagging na tinatawag. And this is it. There. So, ito yung bending or sagging na nangyayari. So, in figure 1, ito yung initial condition or position ng beam which is horizontal or it is straight and there are supports at the ends. Then, under the action of the loads, nagbend yung beam or nagkaroon ng sag or sagging. So this is just an example because the forces are downward. So ganito magkakaroon ng effect doon sa beam. Parang smiley yung itsura. Now let us first define or discuss types of beams according to supports. Although yung iba dito familiar na kayo, like the statically determinate beams. In one of our topics, we discussed about statically indeterminate structures. But here, bibigyan natin ng i-group natin yung statically determinate and statically indeterminate beams para makita natin yung kanilang difference sa itsura at sa supports. Now, statically determinate beams are beams in which the reactions of the supports may be determined by the use of the equations of static equilibrium. So this is the simply supported beam. Meron tayo ditong beam and then ang support ay combination ng hinge at one end and a roller at the other end. This is also simply supported, kaya lang, mas tinatawag natin to na overhanging beam. We have a hinge and a roller, pero may extended portion nito at free end. Then we have cantilever beam. One end is fixed, the other one is free. And another overhanging beam, but this time, two ends are extended. So, simply supported pa rin to dahil combination ng hinge at saka roller, but two ends are extended without supports at the ends. Now, let us have the statically indeterminate beams. By the way, again, yung statically determinate kanina, lahat yon ay pwedeng ma-solve ang reactions by using the equations of equilibrium. Unlike these statically indeterminate beams, na as defined, yung number of reactions exceeds the number of equations in equilibrium. That's why we need to formulate additional equations, or as we have seen in one of our topics also, besides the equations of equilibrium, meron pa tayong ginagamit na compatibility equations. So here we have continuous beam, meron tayong hinge and a roller and another roller. So we call this as redundant support. So in this case, this is statically indeterminate kasi if we will compare this with the statically determinate na merong hinge at isang roller, so we can readily solve for the reactions. But here, there is another support. So additional reaction ito na kapag binilang natin yung available equations to solve for the reactions, so we will be needing additional equations. So this is a restrained beam. As you can see, two ends are fixed. So we have here 6 reactions. Kasi bawat fixed support ay merong vertical, horizontal, and a couple. So kung sa kabila, ganun din. So we have a total of 6. Pero kung bibilangin natin yung equations of equilibrium, maybe we can have summation of moments, summation of vertical and horizontal, pero kukulangin pa rin yung equation. So we will need additional equations for this. Then there's what we call as the prop beam. So yung prop beam, fix yung isang end, and then the other end ay hinge or pwede rin na roller ito. And we have a compound beam. So we have here two beams, beam 1, beam 2. Yung beam 1, fixed at one end. Beam 2, may hinge sa isang end. And the two beams are connected by what we call as a link. So these two beams form a compound beam and it is statically indeterminate. So these are the same pictures that I showed earlier, but this time I want to give emphasis on the types of beam according to materials. As you can see, the beams in the pictures use different materials. Merong made of concrete, merong steel, merong wood or timber. Now, this slide is a review of the types of loads na possible na dalhin ng isang beam. Pero pinagsama ko na dito sa isang simply supported beam. But in our examples, we will see combinations of any of these loads here. So we have what we call as concentrated load, or sometimes ang tawag dyan ay point load kasi naka-apply sa isang point. Then we also have the uniformly distributed load and the uniformly varying load. And itong uniformly varying load, pwedeng ito ay triangular load, but in this case, it is trapezoidal, which can also be broken down into two regular geometric shapes or loads na isang triangular at isang rectangular loads. But it depends on how you will analyze it. And there's also a couple. A couple is also a load. And we know that a couple comes from a pair of forces which are parallel with the same magnitude but oppositely directed.